Hey everyone! In this video, we're going to be looking at some of the applications for ratios and proportions. So I have two examples I'd like to take a look at. In each example, we're going to set up some ratios. One piece of these ratios is going to be unknown, and we're going to use proportions to solve for this unknown measurement. So the first example I have says, suppose that a rectangular room has a length of 18 feet and a width of 12 feet. An architectural scale drawing of the room is made so that the length of the room is 4.5 inches. Two questions I want to answer: what will be the width of the room on the drawing, and what is the scale factor? So taking a look at the picture that we have to go along with this, I know the actual length of 18 feet, I know the drawing length of 4.5, I know the actual width, but we need to find this drawing width. We need to find x. So the first thing, let's set up a couple ratios. Let's do one ratio for the lengths, so the length of the actual room and the length of the drawing, and we'll do a second ratio for the widths. So a ratio is just another way to say a fraction. So we want to compare the two lengths that we have. So we're going to set up a fraction, and I'm going to do the actual length divided by the drawing length. So plugging in what we know, the actual length is 18 feet, and the drawing length is 4.5 inches. Now the first thing I'm going to do here is I'm actually going to change 18 feet, and I'm going to convert this into inches. In this ratio, I do want these units of measurement to match in the numerator and the denominator. So 18 feet multiplying by 12, we end up with 216 inches. And now our units match. Let's do the same thing for the width. So we're going to set up another ratio. And now, because I started off my first ratio with actual over drawing length, I want to do the same thing for the width. So that's one important thing to note about proportions when we're applying it, is there are multiple ways that we can set these up. We just want to make sure that we're being consistent. So because I set one of them up as actual over drawing, I need to do the same thing for my other ratio. So we have 12 feet, and then this is going to be over x inches, which is our unknown. And then again, let's just change this into inches. So 12 times 12, 144 inches over x inches. So now that we have our two ratios, we can set them equal to each other to get our proportion. So 216 over 4.5, that's going to be equal to 144 over x. Notice I didn't include my units of measure here. I have inches on top and bottom, so I don't need to put them anymore. Now to solve this, we can use our cross products, so multiplying diagonally. So that's going to be 216 times x, and then 144 times 4.5, that's 648. And then to finish up, dividing both sides by 216, we end up with the width of our drawing is 3 inches. So here's our unknown measurement. Now the last piece, the last question here is, what is the scale factor? So the scale factor is how I go from one of these measurements to the other one. So how do I go from the drawing length to the actual length of the room? In other words, how many times bigger is the actual room compared to the drawing? To find that out, what I can do is just compare our two measurements. So let's compare the actual length to the length of the drawing. So this fraction right here. If I simplify this fraction, 216 divided by 4.5, I end up with 48. So a couple ways we can write this. A lot of times we use the variable k to represent scale factor. So I could say k, my scale factor is 48, meaning the actual room is 48 times larger than the drawing. Or I could say that I have a ratio of 48 to 1. So either way here, both of these will work for our scale factor. All right, let's go through one more example. This one says a landscaper is designing a garden for a house that is not yet built, and needs to determine the length of the shadow the house will cast. The landscaper, who is 6 feet tall, measures his shadow to be 8 feet long at a particular time on a sunny afternoon. If the roof line of the house will be 15 feet high where he is standing, how far away from the edge of the house will the shadow extend on the same time of day? Okay, so we're comparing a couple of things here. We're comparing the height of the landscaper to the length of his shadow, and then we want to compare that to the height of the house, and then how long the shadow of the house is going to be. So again, we can do that with proportions. So I'm actually going to start by drawing a picture. So in both cases, we have a shadow and we have a height, and this basically forms a triangle. So I'll say that this is the person. So the person is 6 feet tall, and then their shadow is 8 feet long. I want to do another triangle that represents the house. So the house is a little bit bigger. So the house is going to be 15 feet tall, and we need to find the length of that shadow. So that's our unknown, x, the shadow of the house. So we can set one up for the heights. We'll do a ratio to represent these, and then we'll also do a ratio to represent the shadow. Now again, multiple ways we can set this up as long as we're being consistent. So let's do the height of the landscaper divided by the height of the house, so 6 over 15. So 6 feet, 15 feet. And now when I set up a ratio for the shadow, I did the landscaper over the house, so I'm going to do the same thing here. So the shadow of the landscaper was 8 feet, and then the shadow of the house was x feet. So just being consistent in how I set those up. Setting them equal to each other, we have 6 over 15 is equal to 8 over x. So here's our proportion. And again, using our cross product, we can solve this. So multiplying on the diagonals, we have 6x. That's going to be equal to 8 times 15. So 6x is equal to 120. And the last step, dividing both sides by 6, we end up with 20 feet. So the house is going to cast a shadow that is 20 feet long. So that's how we can use ratios and proportions to help us find unknown lengths. In these two examples, they're pretty specific, but this idea we can apply in many different situations.